Alright, so we start off with the solenoid here, which is connected with this switch here. When that goes through, it creates a magnetic force which holds this steel ball here up against that. When we remove the switch, this is going to fall down and go down this ramp and connect these two wires here because it's a conducting ball. When it does that, it's going to send a current, a very strong current, through the highly resistive steel wool, which will then short and catch fire, popping the balloon like that. When that happens, there's a ball in there that's going to be released. It's going to follow down this track, hit this here, which then knocks this ball here. It's going to travel across here, fall down, hit this can of nails down. When it does that, it's going to pull this and this out, allowing this ball to release. When that ball releases, it's going to fall down, hit this plunger, which then knocks the ping pong ball. Because the ping pong ball is buoyant, it's going to bounce up, 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 hit this. This is going to fall down, knock this up. This ball will fall down. This ball will hit this one, which is a heavier ball. This ball will hit down, knock this weight off the table, which will then pull the string out of here, pulling the duct tape off the side of the hole in the Sunny D can, allowing the Sunny D to fall down in the cup down here, and then you will be able to drink it.
Yay!
Alright, now our first step is a solenoid, which makes use of magnetic energy through electrical currents. Now, as you can see, we have a switch up here. Now, this switch connects here, which connects the current involved with this 9-volt battery, which then spins around here, and, well, you can see this magnet is where it would be, but there's a bolt that goes straight down to the middle of this solenoid here. Now, when that happens, we get magnetic force through the current, and it can hold, as you'll see, it's connected here. Now, if you go down here, you'll see the magnetic force holds, holds the ball up there. Well, it should. The battery appears to be a little weak. Alright, well, it does, as you saw in the video, because that's how we started it. So we hold it on, and then we pull the switch, which then disconnects it and removes the magnetic force. Like now, there's absolutely no force holding it there. Before, there was. Alright, now, when this ball releases from the solenoid up here, because of the magnetic force, it's clockwise, so it's holding it up. Alright, if I don't drop it, it rolls down this ramp along this track, and in here you can see there's two wires protruding from either side of this track here. Now, when this ball, which is magnetic and also conducts electricity, when it touches in there, it acts as a switch, sending a current from two 9-volt batteries underneath, sends that current through these wires and through this piece of steel wool. Now, because the steel wool is so thin and has such high resistance, and you're putting so much current through it, the metal itself actually fails and catches on fire, which pops the balloon. Hopefully this will work. You can see that. Oh, where's it? There it goes. And you can see it catches fire because and then the heat causes the balloon. Alright, now after the balloon pops, there's a marble sitting on this track here. Now, when that happens, all this gravitational potential energy starts converting into translational kinetic energy, which then rolls down here. Now, when that happens, it'll hit this, which when this happens, it sits here and it knocks this, which then transfers its energy to this. So therefore, it's now going slower than before. It becomes rotational kinetic energy. Now, when that happens, there's another ball up here, and that hits that, which then translates its rotational kinetic energy, because it stops right here, translates its rotational kinetic energy into translational kinetic energy, which then adds to the gravitational potential energy, shooting this marble down here. Now, then we'll move on to the next. Now, as this kinetic energy, rotational and translational kinetic energy, shoots this marble off, it shoots, and as it hits, all that energy shoots it right across. It hits this and transfers into this. Now, from momentum, we know that when this hits, it's going to transfer just a little bit because this weighs so much more. Now, and also because it's top heavy, it's going to knock a little bit, and this will just fall right over because of. Alright, now the gravitational potential energy of this falling off being converted into kinetic energy pulls this string here, which then will overcome the force of friction holding this block here. This pulls out, and there's a large marble up here. We'll show it with this smaller marble. When that happens, this is sitting like this, and it drops, allowing the kinetic energy to take over, shooting this down here. Right, now this ball is going to fall down and form an elastic collision with the metal rod here. Now it's kept airtight because of this balloon here and the suction. Now when that happens, that hits this. Now normally this tank is full of water, and because of Newton's flotational laws, we can see that this ball will shoot up because it has a lower flotational constant than that of the water. It's going to shoot up, and then its flotational kinetic energy then the flotational kinetic energy hits this. Now, as a result of that, the flotational kinetic energy is converted via rotational kinetic energy into translational kinetic energy and gravitational potential energy, which makes this fall down. When that happens, you can see this lever over here will transfer the energy going down to the energy going up. Now when that happens, it hits this dowel rod, which shoots up through this hole, knocking this ball down. Now, when that happens, the gravitational potential energy turns into translational kinetic energy, which you just saw as it goes down. Now, when that happens, it forms another elastic collision with the bigger ball that sits right here. Now, when that collision happens, because of conservation of momentum, this will shoot down farther. Now, it will go along, its gravitational potential energy slowly being changed into translational kinetic and rotational kinetic energy. Then it will drop, and it will reach an essential point of zero with its gravitational potential energy because it's on a flat surface. When that happens, it will go and form another elastic collision, which then causes this weight to fall down. Now, when this weight falls down because of the elastic collision with this ball, it's going to fall down. There's a string attached to it that reaches up to a piece of duct tape. Here, I'll lift this up so you can see. There will be a piece of duct tape covering this hole here. Now, when that happens, the water pressure will eventually force this open all the way, along with the combined force from the energy of the falling block there. It will rip this off, and because there's open on the top, so there's room for air to get in, the water, or Sunny D in this case, will shoot out of the bottom. Now, when that happens, it's going to shoot down through this hole, and there's a cup underneath, which is not there now. Where's the cup? You recording? Wow.
Oh, it worked. Yes. Oh my god.
Well, you can't see, but it's filling up with water. Don't worry, we'll show you when it's done.
Oh, it's so hot. Yes! Boom!
Yes! It's
Yes! Fill it up.
Fill it up. Alright. That's good.
All ridiculous about it.
It doesn't matter.